Hey there, welcome back to our channel. We're carrying on with our Unity targeting system tutorial today, and I'm excited to dive deeper into updating our targeting manager script. Now, you may have noticed fewer videos these past weeks, and there's a good reason for that. I've been knee-deep in developing a new platformer game where your main mechanic is controlling gravity. Imagine yourself as a tiny robot trying to escape from a research facility where the latest experiment has gone a bit haywire. Sounds thrilling? So, if you're interested in hearing more about the development process of this game, drop a comment below and let me know if you'd like to see some devlogs. But for now, let's focus on expanding our targeting system in Unity, even though today's video is a bit shorter. I promise it's jam-packed with crucial information. So, without further ado, let's jump right in and enhance our game development skills. Time to dive back into our targeting manager script. Remember the onTriggerEnter and onTriggerExit methods we've previously set up? Well, now we're ready to make our game identify and select a target. So, we'll begin by constructing a new public method dubbed selectTarget. This method will return a Boolean value, indicating whether or not a target has been selected. Inside our selectTarget method, we need to confirm if there are targets within range. If none are found, so if targets.count equals 0, the method will return false. Now, at the top of our script, let's create a new variable called currentTarget of type target. We'll make it publicly accessible but privately modifiable property. Now, let's return to our selectTarget method. After checking the target count, we need to cycle through all our potential targets to find the one closest to our player. So, we'll loop through each target in our targets list using a for each loop. For each target, we get the target's position on our screen with vector2 view pose equals main camera dot world to viewport point, and we want to pass in the target.transform.position. Now, we do not have yet the main camera. So, at the top of the file, let's make a private variable called main camera of type transform. Now, let's create the start method, and inside the start method, let's set this transform to main camera. Now, back into our loop. After we get the viewport point, we need to ensure that the X and Y components of this position lie within the bounds of the script, so between 0 and 1. If a target is not within our screen, we simply continue with the next one in the list using the if viewPose.x smaller than 0 or viewPose.x larger than 1 or viewPose.y smaller than 0 or viewPose.y larger than 1. We continue. Just before this loop, we'll introduce two more variables. Closest target of type target, and we set it to null, and float closest target distance. We need to set closest target distance to math.infinity. So basically we want the largest number possible that we can set this variable to. This helps us ensure that the first target we find will always be closer than the closest target distance. Now, back inside the loop, we calculate the distance to the center of the screen with vector2 to center equals viewPose minus new vector2, and we do 0.5 for both X and Y, which will bring us in the center. If this distance is less than the closest target distance, the current target becomes the new closest target and its distance becomes the new closest target distance. Once we've stepped out of the loop, we verify if the closest target was found using if closest target equals null and if that is true, we return false. If one was found, we set our current target to equal closest target and return true. Lastly, we'll introduce another method called cancel. As of now, its job is simply to reset current target to null. Let's move on to modifying the player state machine script. We're going to establish a serialized field for the target manager using the following code. Field, serialized field, public, target manager, and let's call it targeter. And this should be publicly gettable and privately settable. Next, within the handle target log, we need to include a check to determine if a target exists before switching to the targeting state. We do this by adding if not targeter.select target. So if you remember, in the select target, we're returning false if there are no targets in range. We should return. This will return from the method if there are no targets within range. Otherwise, it'll transition to the targeting state. Lastly, inside the handle target unlock method, we should invoke targeter.cancel. This ensures that our current target is reset whenever we unlock the target. Great. Next, we will add a few debug messages on our player targeting state, so we check if our new targeting calculations are working correctly. Let's wrap things up. Within the update logic method of our player targeting state, let's incorporate a debug.log statement to verify our current target. We can do this by adding debug.log current target plus player state machine.targeter.current target.gameObject.tag. Now, we need to go back in Unity and we should add tags to our two spheres. Let's create these tags first. Now, I'm gonna call mine dummy1 and dummy2. Not very creative, but it doesn't matter. We just need to see if it works. Inside the player state machine of the player game object, we need to link the target manager to the targeter field. Simply drag and drop the target manager onto this field. Now, let's give it a test run. You will see as we approach a sphere, the console will log the appropriate tag once we click tab. Similarly, as we move out of the field of view of one of the spheres, it will switch to the other sphere. Excellent. In our next video, we'll dive into using state-driven cameras to alter our perspective during targeting. Stay tuned.